Where did I close the? Oh, there it is. Hello and good day, Algebra. We're moving on to PO28. Nothing like starting out 2023 with a PO. Warning for you, sir. And it's all about parallel and perpendicular lines. Looking at how to tell, given two equations, what the relationship of those lines are. Now, next year, you're projecting to be in geometry. And in CO1, we're going to define geometry as the study of relationships, okay? Because it really is. It's how do things fit together? What is their relationship? And this is a piece of that, okay? So first of all, what do we know about parallel lines? What are lines that, what makes them parallel, or what's their definition then?
Parallel lines, they're like they're equal and next to each other.
What do you mean by equal?
Like they're the same length.
Well, a line technically doesn't have a line. Never cross, okay? Parallel lines are lines that never intersect. Okay? Now, maybe you've never stopped to ask yourself, why would that be? If you've got two lines that are graphed on the coordinate plane, I'm just going to make a little makeshift coordinate plane here, try and do my best to make parallel lines there. What about those lines would cause them to never intersect? Think about what we know about lines and how they move across the coordinate plane and just generally what gives them their shape. Why would they be parallel? What about them, Cole?
Because they go on forever.
The lines do go on forever. That's not why they wouldn't intersect, though. Katie? They have the same slope, right? Remember that what determines how a line moves across the coordinate plane is that slope. Ryan, what makes two lines parallel?
Lines that never intersect.
Warning for you, sir. Okay, please stop talking and pay attention to what's going on up here. Parallel lines will have the same slope. Okay, what causes lines to move across the coordinate plane is that rise over the run. If two lines have the same rise over run, they're always moving up or down the coordinate plane at the same rate, right? It's kind of like, if you're 1 day older than your best friend, will your best friend ever catch up to you in age? No, you'll always be 1 day older, right? Because you're aging at the same rate, 1 second per second. Okay? So if line A has a slope of 2/3, a line that's parallel to it will have a slope of?
4/6.
Some said 4/6. Okay? It's going to be 2/3, but note that 4/6 does simplify to be 2/3, right? Which is why when you already asked, should we simplify slope? My answer is always yes. If you do have a line with a slope of 4/6, because it simplifies to be 2/3, it would be parallel to what you have here. Okay? But those slopes will be the same. Right? If line A has a slope of -9, a line that's parallel to it will have a slope of -9. Okay? Cole, I need you to stop. Right? That back row, the two of you, I need you to stop. The slopes will be the same. Okay? They will go up or down the coordinate plane at the same rate. Perpendicular lines. Another special relationship. What are lines that are perpendicular? Paisley?
They're lines that cross.
Lines that intersect, but they intersect in a special way. Do you know what that way is? Colin? At a 90-degree angle. Okay? Lines that intersect at a 90-degree angle. And what does a 90-degree angle look like?
A right angle.
A right angle, right? The crucifix over there on the wall, right? The two beams intersect at a 90-degree angle. My shelf over there, the horizontal and vertical boards intersect at a 90-degree angle. They are perpendicular lines, okay? So not only lines that intersect, right? Those lines intersect, but they're not perpendicular because the angle that they make is not a right angle. It's not 90. A right angle, as you know from previous geometry, right, straight up and down. Okay? Two lines that are perpendicular. This one might be a little bit more difficult to visualize. It has to do with their slopes, right? But in order for two lines to intersect in that way, Naveen?
Oh, is that opposite?
In what way? Because you're right, yes.
Like one will be positive, one will be negative.
Okay, and there's one other thing. The signs will be different, but also, Colin? Katie? Yes. It's called negative reciprocals. Okay? They'll have slopes that are negative. I'm going to erase my diagram over here so I can fit the word. Negative reciprocals. Okay? Negative reciprocals. And we know what the word negative means, right? It means opposite, you know. And so Naveen said their signs will be opposite, and that's true. One will be positive, one will be negative. As Katie said, the rise over run will flip. Reciprocal, think of a reciprocal of fraction, right? You flip it upside down. Okay? So if line A has a slope of 3/5, the negative reciprocal of 3/5 will be what? Negative 5/3. Okay? The sign will change and the fraction will flip. Naveen said they're opposite. That's truly opposite, right? It flips and the sign changes. And so if you have a slope of -7, the negative reciprocal of -7, Maddie?
Positive 1/7.
Very good. Positive 1/7. This is where it's important. Remember that even -7 can be written as a fraction as -7/1, right? So that fraction is still going to flip, become 1/7, and the sign's going to kick the positive. Okay? Questions on that relationship?
No.
All right. Any other lines that have slopes that are not the same or not negative reciprocals will just be regular lines. They'll intersect, such as these lines here, but it won't be a right angle. There's really nothing special about them. Sorry, you're just average lines. Okay? All right. Your job, our job, I'll go over some of them for you here. Determine if line A and line B are parallel, perpendicular, or neither, and explain. If they're parallel, you're looking for slopes that are the same, right? If they're perpendicular, you're looking for slopes that are negative reciprocals. And if it's neither, it's going to just be not one of those things. Anything else, right? If they're not the same, if they're not negative reciprocals, they're neither of those two things. So, line A, y equals 4x plus 3. Line B, y equals -4x plus 7. All we care about is the slope. Raise your hand if you think those lines are parallel.
No.
Raise your hand if you think they are perpendicular. Raise your hand if you think they are neither. Raise your hand if you don't like poles. Very good. Okay? They are neither. Okay? They're not parallel because they're not the same. One's positive, one's negative. That's not the same slope. If you think about on the corner plane, one of them you're going up 4/1. Your line will look like that. The other one you're going down 4/1. Your line's going to look like that. They're not parallel. Okay? They're also not perpendicular because they're not negative reciprocals. The signs are different, but the reciprocal of a +4, this would have to be -1/4, not -4. Okay? So the correct answer here is that they are neither parallel nor perpendicular, and the reason why we just explained, they're not the same slope, they're also not negative reciprocals. Next one, line A. The slope. Again, all we care about is the slope. 2/3. Line B, 2/3. Raise your hand for parallel. I should see 33 hands up in the air right now. Okay. The slopes are the same. Therefore, the lines are parallel. If you think about how these look on the coordinate plane, both of them are going up to over 3. Okay? They move the same way across the coordinate plane, so they will never intersect. The bottom line will never catch up to the top one because they're both going up to over 3, up to over 3. So they are parallel. And lastly, y equals negative 3x plus 8, y equals 1/3 x plus 14. Focus on those slopes. Are they parallel?
No.
No. Are they perpendicular? They are. Okay? The negative reciprocal of a negative 3, the sign is going to change, and we're going to flip the fraction. So negative 3 over 1 becomes positive 1/3, which is exactly the slope that we have in line B. Okay? So these are perpendicular because their slopes are negative reciprocals. This is the gist of the lesson right here. This is the only new piece. Everything else beyond this goes back to last unit where you have to convert in slope-intercept form, find the slope, blah, blah, blah. So if you understand this, you understand PO28. The rest of it goes back to what we've done before. Any questions on these three? To start, I'll get to you in a second. No, all right. Hit me.
So is that one, the one with 4x minus 2y, is that one with parallel?
We'll do that one together. Okay? Sam?
Which one?
Give back.
I
Hey, folks, I don't have time. Give it, just return it. Whatever. The next section, what form are these lines given to you in? Standard form. Does standard form tell you what the slope of a line is? No. So what must you do in order to determine whether or not they are parallel, perpendicular, or neither? Cole? Convert it to slope-intercept form. So this goes back to PO22, right? Or 24, 22, where you have to convert back. So line A, 4x minus 2y equals 12. Our first step is to move that x term over, right, using opposite operations. So we're going to subtract 4x from both sides. That gives us negative 2y equals negative 4x plus 12. Right, that x term goes first, as slope-intercept form is written in. Then divide everything by negative 2, and we get y equals positive 2x minus 6. Do we care about the minus 6?
Yes.
No. All we care about to determine perpendicular, parallel, or neither is the slope. The y-intercept could be anything. Okay? All we're looking at is the slope. So, line A, converting the slope-intercept form, y equals 2x plus 6. I'm going to put a little 2 up here, because I'm going to erase my work here so I can put the second one in there. But just so I remember, the slope here is a positive 2. Line B, negative 8x plus 4y equals 4. So to convert to slope-intercept form, we're adding 8x to both sides. Opposite operations, move that x term over. So 4y equals 8x plus 4. Divide both sides by 4.
Oh, it's a negative 4, by the way. What? It's negative.
Oh, negative 4. Thank you. Thank you. Good thing our y-intercept doesn't make a difference. But yes, divide everything by 4 then. Get y by itself. And 8x divided by 4 is 2x. The y-intercept is a negative 1, but we don't really care about that because in order to look for parallelity or perpendicularity, all we care about is the slope. The slope of the second one is 2. The slope of the first one is 2. So what's the relationship? Parallel. They have the same slope. Okay? They have the same slope. The next two in this section are pretty much the same thing. Okay? You're putting it into slope-intercept form. Don't let line B on that third one confuse you. You have x's on both sides. That's okay. your first step is still going to be subtract 20x from both sides, only instead of having no x's on the right side like you're used to, you already have -4. So -4 minus 20, you'll be right in the same spot you would be anyway. Okay? The next section, I give you 2 ordered pairs that each line passes through. What do you need to do? All we care about is the slope.
Find the slope
How do you find the slope?
by doing the subtraction of x2 and x1.
y2 minus y1 over x2 minus x1, right? Both these sections here involve POs from Unit 3, which is why they were POs in Unit 3, right? Because we're using them now to do other things with them, okay? So the importance of those POs and staying current with them is that if you've not become proficient in converting from standard form to slope intercept form, PO28 is now harder than it could be, right? If you're not proficient with that slope finding formula, then PO28 just became harder than it could have otherwise been, okay? So the POs are there for a reason. If you've not made a New Year's resolution yet, make it that you get all caught up with your objectives by the end of the month. And then stay caught up, right? That'd be a good one, I think. Okay? Your homework for tomorrow is to stop before the brain buster questions. Okay, so just the 5 that we have not done together, the other 2 on the first page, and then these 3 on the back side. If you did the bottom, kudos. You do need to do the review at the end.
What?
Okay,
So we don't need to do
so you're essentially skipping the brain buster part. You need to do the rest of the 6 that we started, skip the brain buster, and then you need to do the time for review.
What's the brain buster?
The middle part. Yeah. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Okay. Be good, folks. That's how you math.